The expensive mistake is not choosing the wrong vector database. It's putting retrieval in the wrong place. Split vectors out too early and you create sync pain. Use vector-only search in a search product and you can miss exact keywords. Keep a hot vector workload in Postgres too long and your app database becomes the bottleneck. So the real question is not which vector database is best. It is where should retrieval live in this product? Start with data gravity. Where does your source of truth already live? If the documents, permissions, tenants, and billing metadata are in Postgres, moving only the vectors somewhere else creates synchronization work. If your product is already a search engine with keyword relevance and filters, vectors are one ranking signal inside that system. If retrieval itself is becoming a high-traffic service, it may deserve its own database. And if you are still experimenting, local tools are faster than architecture meetings. Before choosing a product, answer 6 boring questions. How many vectors now and 6 months from now? How often do they change? Are filters simple or are they tenant, permissions, and complicated metadata? For many RAG apps, the default answer is boring in the best way. Use Postgres with pgvector. You keep vectors next to the road they describe. You keep joins, transactions, backups, and the security model your app already trusts. It supports exact search and approximate indexes like HN, SW, and IBFFLAT. This is the move when you are small to medium, your filters are relational, and operational simplicity matters more than squeezing the last millisecond out of search. The warning: if vectors become your hottest workload, Postgres can become the crowded room. Then you measure, not guess. If the product is search first, don't throw away the search engine just because embeddings arrived. Elasticsearch and OpenSearch can store vectors, run nearest neighbor queries, and combine them with full-text search, filters, faucets, aggregations, and re-ranking. That's what you want for commerce search, doc search, logs, and support portals, places where exact words still matter. Vector-only search can mean the SKU, error code, or product name the user literally typed. Dedicated vector databases earn their keep when vector search is the product, not a side feature. Choose a managed service when the team wants low ops, cloud regions, capacity controls, support, and predictable production knobs. Choose an open or self-hostable engine when control matters. Data residency, private networking, custom deployment, or deep tuning. Pinecone feeds the managed service lane. Qdrant and Weaviate are common choices when you want more deployment control, strong filtering, and a database built around vector workloads. For prototypes, local evaluation, and research, reach for Chroma or Faiss. Chroma gives you a friendly AI data store for retrieval experiments. Faiss is a similarity search library, not a full database, and it's excellent when you need to test indexes, memory, GPU path, or offline evaluation. Just don't accidentally ship a notebook as your architecture. The thing that works for one developer on one machine is not automatically multi-tenant, observable, backed up, or easy to rebuild. So here is the practical default. If your app data is already in Postgres, start with pgvector. If the product is search first, add vectors to your search engine. If vector search is core infrastructure at serious scale, use a dedicated vector database. If you are learning, prototype locally before buying architecture. Pick the constraint first, then pick the database.